I'm going to start by showing off this membership stuff a little bit again. So if I don't know if everyone knows this yet, but this Mr. Fourth Base stuff that I'm working on, it is going to come out as public, open source code eventually. You can, go over to, like, if you're here, you go over to get.mrfourth.com. You don't have to sign in or anything. You just explore. And, I don't have a Mr. Fourth Base.h here yet. There's the old version of the code base right here. This is like the free open source version. It is not up to date with what I have now, but there's other stuff I've worked on here, experiments and example programs and stuff. But if you are, if you're a member, which I'm signed in with my membership account, my account has membership access, you can get access to the like live version. So the code base I'm working on today in its sort of alpha unfinished form. If you're interested in that, that's actually one of the perks of being a member, is you could check out the code directly. And there's also this index of the video library. So you can come in here and we're still building out. So we have everything up until everything from the 2021 series. We're still building out the graphics stuff is coming online soon. And then, we'll do the couple of like isolated updates I've had here and there as well. But all of my videos from the code base stuff and my essays and stuff too will all be right here. So you can just like search and find out where in a video is the thing you're interested in, right? And you can like jump around and find other interesting parts of the video pretty quickly and all kinds of cool stuff. The video library stuff is really cool. So, yeah, you get that by going to mrfourth.com/membership, and you can check out all the stuff we have right here from there. All right, so today I am getting back to the Mr. Fourth Base stuff. I want to work on the runtime linking, the DLL bridging. So, very first thing, I'm gonna need like a target, a test target, right? I don't have that yet. What is this, Mr. Fourth Base? Okay, right. So I do have it actually. Let's see, what was I doing though? Yeah, this didn't get updated. I don't have it in the testing main. What is this? Testing library. Mr. Fourth sim link time. Let's do it like that so you don't have to use both of them side by side. There we go. All right. So, what we want to do is build these. Let me read through this because I didn't remember I had this test. Let me read what the test is doing. So, we're doing lib begin, lib tick, lib end. That's matched to that. And then load library. So, testing library is going to go to a DLL. We're going to load that in. We load in lib begin, lib tick, lib end. And then what we're trying to do here, I guess, is... Right, we're trying to see if the log, right? Okay, so this is testing if the log between the two will be merged. So, okay, if we, let's read through what happens. We begin accumulating a log. We emit the beginning here. We begin the log. We call these things, each of these will print out some stuff specifically like from that particular function, and then we interleave it. At the end, we grab the accumulated log and we write that out. So we'll only see whatever ends up in the log that is visible to this binary. And the question is, can we get it so that these two act as a single log? If I build this right now the way it is, it should fail. It should be that this side and this side aren't actually successfully... we'll be able to load these functions in and call them, but they will actually be going to a separate log, right? In fact, we won't even be able to build this part because I'll need to do it like this. Okay. So let's start with that. I need to be able to build these. Let's see if my build script's actually targeting or testing main. Yeah, okay, so I do have the scripts for building this already. I don't have the ability to build DLLs in the build system, you say. Ooh, we might need to do a sidetrack thing and just work on the build system if that's true. The alternative is to just not use the build system and build by putting in a CL line, right? Just run the compiler directly to build the DLL. But no, let's do... let's do... yeah, let's do the build system. So BLD core. First of all, I guess I want to let's start with like testing build.bat, add echo off. Let's just do we'll do vars here, CL, put on my diagnostics and run that. And that should generate some error somewhere along the way, I assume. Testing main. Right, here's our error. Our entry point must be defined. So the testing library tried to make an executable file instead of a DLL because we don't have the ability to build DLLs in the build system yet. That makes sense. Here is the... because I got my diagnostics on, I can grab the full build line for both. Okay. And now I'm going to turn off my diagnostics. I'm going to... we're going to go over to my project file. And we're going to add in a new what is this? This is a testing build. Compile. Compilation. Footer panel equals true. Give me this right here. And then we'll do right, so these like to run from root, so testing slash, I guess forward slashes work here. Testing slash testing build dot bat should do it. Let's reload the project and test that out. Testing build. Not recognize an internal external command. Right, so you don't like that actually. What if I did this? Whoops. Load project, testing build. Testing is still not working. No, okay, so you do like the backslash for the batch. Why are you... Let me just double check here. Where is the project file? Right, okay, there it is. Load project. Testing build. Testing. Okay, so I probably need to use a double backslash maybe? I forget exactly if I... Right, okay, so you don't... Right, you don't want that syntax. Of course, that is the funny way that the bash stuff does it, but we want to do it like this. And similarly, you don't want this like this. You want all of your forward slashes to go backwards. Okay, so now we're just down to how do I mark this as a DLL build? So let's come over here. I'll put all the Mr. Forth advertising stuff into a group here. Mr. Forth, all right, and we'll hide that away for now. We want to look at Microsoft compiler options. Okay, we are looking for DLL. Compiles to create a multi-threaded DLL. By using MSVCRT DLL. Maybe... Let me also look at link options. This might be a thing where I just need to mark it in the linker. Let me also check one other thing. I had some experiments. Yeah, let's go. Let's go actually, I made a reference for this. Let's go to mrforth.com. We want to look at shareable binaries. Here we go. CL, okay, yeah, here we go, perfect. CL wants /LD. And let's see if that does it. That says it should have worked, but it sort of kind of doesn't look like it did. Unless I'm hitting F, right, okay. So what I need to do is I need to actually modify my project to run testing build now. Right, so this line here isn't quite working actually. Okay, take this back out. It should have the source folder in its include path. right? Mr. Forth source, Mr. Forth base H. So what am I missing here? C colon, Mr. Forth source. See, that can't possibly be. Oh, this one here though, I did not convert. There we go. Okay, so now, wait, it built testing library.c? Why would it do that? That should be failing. What? Right, because this has no main. Right, so when I'm doing it this way, build fly load project F1 link entry point must be defined. Build fly. Oh, this is just compiling. Okay, I need to run diagnostics again because I did not get the whole picture. Yes, it ran CL right here. It also ran the linker right here. And again, right here. Okay. Missed that, but there we go. Now we're back. Project, testing, build. Load that project. And now if I do this, we get our, okay, there's our error. Comes from running the linker part. So if I do LD right there, then I want to do dash DLL right there. Okay, so those are the changes that need to be made. So some of those are easy. Compiler flags. What we're going to do is we're going to say do I have over here in my... No, okay. So if we have the compiler CL and we're building a DLL, then we need to add dash LD. Okay. Put a to-do right here. DLL support for Clang is not done yet. We want to do linker flags. If we do link MSVC DLL, then we want dash DLL right there. And then the last thing is this file extension. It comes out as a .dll. I have like a file extensions thing here. Oh, and it already knows about DLLs. So that's interesting. That's interesting. Do I... Let me look at the diagnostics real quick. And then we'll... Whoops, don't do that. We want to do build fly. This time I want to look at the options coming out for compile right here. File extensions. Let's look at build core or BLD core. When does the file extensions thing come into play? BLD extension DLL. Okay, so we have this thing that says is DLL BL. Okay, so we already have a thing that says if we have DLL in the options, make the file extension appropriate. So that's cool. We're going to get the right file extension automatically. Must have been planning ahead for that, but we didn't have the compiler options. So with everything that I just did for the compiler options, now we should be able to do, let me turn off the diagnostics. And we should be able to do build fly. Okay, so maybe the problem is testing build fly. Maybe this needs to get the DLL mark. Maybe that's the last piece that's missing. There we go. There we go. Okay, so that is good. Let's also, just for fun, try this out in Clang mode. And that just worked? How could that have just worked? Surely I need to have changed something. Oh, well, that's why it looked like it worked. And over here in testing, we can actually delete the batch script now. Project, don't need the batch script runner. Here we go. Okay, so just to clean that up, if I turn off diagnostics, we run it. Here's our error again. So it's saying it cannot build, it cannot finish this DLL. But that's going to be because we're running Clang as a linker. And we are not doing this, I think. I think this right here says that's what you want to do. Okay. Turning off diagnostics just to be able to read it. Cool. Okay. So that wasn't too much of a diversion. The build system now supports building DLLs. All I have to do is add a DLL tag to the or option to the list of options. Okay, so now we are building the test library. Let's pop in over here. Can I run that? Testing. Okay, so we want to go to /testing main, I think. Yeah. Okay, cool. So check that out. I now just ran this and we got, well, what did we get? We got process beginning, then silence, process tick 4 complete, silence, process complete. we didn't get any of this, right? That's the whole thing. So we linked these in, but the log that this is writing to is actually separate. And the reason for that is that each of our executables or binary files, our exe file and our DLL file, are each creating their own copy of the base layer. And so when this does logging, it's doing logging to its copy of the base layer. And therefore it is not talking to the data structure that does this logging. Okay. Now the fix for that is that we have to start linking our base layer across across the boundary. Now a couple things have to change. One, I'm not calling OS main init, and I actually have to do that from now on, because that's where I'll have the opportunity to do any initialization code that will allow this linking to work. Now, the next thing I have to do is let's just start with the log stuff. There's a few things that are like this. The log is like this, the error system is like this, and the scratch pools. So really the trick is anything that's a thread local, right? Anything where I did a thread var here, yeah, those three spots, I need to actually make sure I'm not creating a separate copy on every binary. Okay? So let's start by looking at the markup that I wrote down. So the markup here is that it's a comp time symbol and it's a thread var. So it being a comp time symbol means that it won't try to link these across objects, let alone across binaries. And it being a thread var means that there's one per thread. Now, the downside to doing it this way is that, well, also, at least in this case, okay. Okay, let's see. Yeah, so what has to happen is this here, it's okay. So the thinking is nothing wrong happens. It is not incorrect if there are several copies of this that are null. That is unfortunate. And so the question is, how could I avoid that? And I don't see any easy way to do it, except to be careful about when you actually include this in the first place, right? Like if I did some pre-processor work, I could say, you know, if Mr. Fourth, you know, oh, let me put it to you this way. So if I have two binary files, and I just were to go, okay, this here is not going to be marked as Mr. Fourth symbol. It's going to be marked as Mr. Fourth, I don't know, it's gotta have an extra mark that's like, or like it has to be a sim runtime, right? It can't be the generic symbol type. It's got to be a runtime symbol always. Then what'll happen is this will exist in exactly one of our binaries, hopefully, and therefore all of the other binaries will not define it, but they'll load it in somehow, right? They'll all have an arena get scratch. We want every binary to have the name arena get scratch being visible and callable, but we want them all to refer to the same one at runtime, to the same arena get scratch, and that same arena get scratch will then will always refer to this. So what we want is that this only gets compiled once, and we have a way to control whether we are compiling the definer of the shared stuff or a user of the shared stuff, right? So then this doesn't become if the markup is right or not. That the markup is fine, but it has to be like if Mr. Forth definitions or shared definitions what is it? It's if we are compiling definitions for shared symbols, if defining symbols, if defining shared symbols, if defining runtime symbols. There we go. Okay. If Mr. Forth define runtime symbols. So what has to happen is by default that'll be off, and then in the case that you're defining those runtime symbols, you'll set that to 1. That means the boilerplate for setting up... Okay, here's the downside. The boilerplate for setting up your exe becomes this, right? You'd have to go... Like, the default way to use this in a standalone exe would become this boilerplate. So maybe I actually want to default to 1, and then you have to, if you're building a DLL that's going to share this, you're going to say define runtime symbols is 0. Or I could invert the meaning of this label. So instead of define runtime symbols, it would be import runtime symbols. That would start off at 0, and then import runtime symbols 1, include base.h, whenever you're doing a DLL, right? So it would be like testing library gets import runtime symbols. And this is if you are not importing runtime symbols. So that's fine, but that's not actually the one I want to test, right? Let's go try this on log. And, well, okay, we've got the idea, but I don't want to put this in yet. What I'm going to do is I'm going to step back for a minute and go over to the log stuff. And we're going to set that up here first. Right. Now I want to go and look at, so each of these is going to be a sim runtime, like that. So they're all referring to the same data structure, and they're all loadable. Now the big question is, how did I expect... I did the research before. Let me go and remind myself. I did this 3 months ago now. Wow. Wow. Okay, so it's been actually a long time since I actually touched this question. Let me look at what I said. Hopefully I did a good job. We'll find out. This repository contains examples of source and build details needed to achieve dynamic linking. Okay, what do we got here? Abstracted base layers. Let's look at that one. Details. In this example, I link everything through runtime linking. The upsides to this are that everything dealing with the linking is in my code, so I can tweak it or debug it directly, and I don't have to have a mix of load time and runtime linking, making the wrangling, that's misspelled, but making the wrangling of keyword abstraction and linker options simpler. There are some downsides too, and in this example I show how I can mitigate these downsides pretty well. The two big downsides I address in this example are symbol declaration and binding gets more difficult in C. Each binary requires some dynamic initialization. Finally, after going over these problems in detail, I will present some details of the solution I use in this example. Symbol declaration problem requires a bit of setup to fully appreciate. Normally in C, you think of your program code as header and implementation. Header file layer.h, right? And then an implementation file like this, blah, blah, blah. Whether we are linking these statically or across object files, it's pretty easy. The header just gets included at all usage and implementation sites as it is. When we transition to linking across binaries, we hit a problem. The reason we hit a problem is that with runtime linking, we need to be directing our calls through function pointers instead of through functions. Reroute from function to function pointer. One way to handle this is to keep header and provide a different implementation file. Dynamic.c. Right, so you just implement the functions differently and have them go through a function table. Then on the side that defines the symbols, we will use layer.c, but in any binary that loads the symbols, we would use layer.dynamic.c, which reroutes the normal function calls to function pointers. This dynamic file is pretty fatty though, requiring several lines of pattern duplication for each function in the layer. Yeah, a metaprogramming system can help here if you want to go that route, but putting another build program in the mix isn't exactly lightweight either. Solution, call through function pointer table. Another option is to say that the place where the issue will pop up is at all the usage sites. Any code written as a user of the layer will switch from calling the layer like this to layer arrow foo. In theory, this eliminates maintenance work, but oh boy, are we in for it the first time we realize we have a helper that wants to work in both the context, because we have one context that's defining stuff and one context that's importing it. And we now have two separate interfaces, so that helper code can't work both ways. Global function pointers. A third way to handle this is to define a new version of the header. In this version, each function symbol that the user wants to see gets replicated, or gets replaced with a global function pointer. Right. So we're just duplicating the symbol declaration. And then I'm using an X list. Well, the downside of an X list is that you don't have a nice clean definition for each symbol. But in this way you can use an X list. Okay, right, so okay. So what would have to happen? So we look at like log accum begin. we might have to replace these symbol definitions, because right now everything's fine, but I would only actually want, I could do this, but I could only actually include, oh, this doesn't need to be like that. This can be a symbol of the old school type. I still need to put right, so I still have to figure out what to do in the other case, right? Now, one thing I could do is I could just commit myself to duplicating the symbol definitions. And this is attractive for at least one reason, which is that it lets it yeah, this might be the way to do it. I could use the XList to eliminate the duplication, but then I would have all of these function symbols hidden in a XList, and so not a part of the readable code. The downside is that the maintenance will be higher, but the upside is that the usability will be higher. Right, okay, so let me explore. I have a couple ideas. Let's try this one first. So this would be like if I did this. Now all the symbols exist. And they can exist as just symbols, like global variables, that initialize to 0 up front. Although I'm going to hit a problem with that where now I'm having the symbol, if I have two, now not talking about the binaries, but the object files. If I have two object files, I have to make sure that only, like, it would actually be like, no, you don't set them all to 0. You just declare them. And then in base.c somewhere, right, like right over here, you'd have to do else, right, grab all of these again and set them all to 0. Here, I think that might be what has to happen. So now we're looking at 1, 2, 3 copies of the declarations have to exist. And if I do it this way, even if I dedupe these two options with a, because you could imagine I could do a macro like this, like a Mr. Forth shared function log accum begin, right? I just do a little damage to the syntax of the language, but I could end up with all of the symbols still being defined where you can see them, and then this macro just does one or the other of these two patterns, right? But since I don't have it as a list, I still have to go and set each one to 0 over here. There could be a thing that's like Mr. Forth shared func null initializer log accum begin, right? Boom, 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 boom. And the way that would work is whenever you do this macro, if you're in the mode where you're defining the symbol, I would use this name twice. I would use it once to create a type def with a modified name, and again to create the symbol with the, that's visible. And then over here, I would just have to list the function names again, but not with their type signatures at least. And it would do the work of declaring from there, or of defining the values, the initial values, right? So the downside, yeah, like, I don't know. I think this is the right path. I think I'm going to go with this for now as the idea. And the reason is that it seems like a good balance between keeping things readable in a single read through. Like, you can find all of you can find all of the declarations. Yes, there's some damage to the syntax. So you'd have to learn how to read this alternative symbol system, like symbol syntax, definition syntax, for any of these shared functions, which isn't wonderful. But the alternative is to, like, do them all twice around preprocessor macros and increase the duplication of the signature. This way, at least the signature lives in one spot, and I don't have to worry about synchronizing the signature across like 3 spots every time I change an API. Right? So it'd go like that, and then you'd go boom, initializer, oops, missed the void on that last. Oh, it's not a void, it's a string 8. Important. Okay, so do something like that, and then we need to go and define those. So those are going to come up here and live. Let's see, they have to live after we've done Mr. Forth, sim, linkage storage, another attribute linkage. Okay, and then we're going to do Mr. Forth shared func. Okay, this is if we are importing runtime symbols, then Mr. Forth shared func is a name, a return type, and a parameter list. And it does type def r and type p and then it does symbol n type putter n, and then it's done. Okay, so that makes our type def for the signature. It uses the name itself so that we can find, you can use that name as the index for the type space, and the R and the P go there and there to create the type signature. Then the name goes in again to create the symbol using that type. But if we are not importing those symbols, then when we tell the system about a shared function using the same signature, we're going to do a runtime. We're going to mark it as a runtime symbol, and then we're going to go the return type, the name, and the parameters, and be done. Okay? So that gives us that. What is, oops, I need to do 2 of these and 2 of these. Shared func. I told you about n. Why? Oh, n underscore goes on that side. Okay, now the initializer is a little different. Func shared func goes like that. Define Mr. Forth shared func initializer. That just shouldn't ever happen. If we're importing, if we're defining the symbols, but it should happen if we're importing them. And it should happen like that. Okay, not far off, not far off. Sim runtime. Right, okay. So I still need to match the signature shown here to the signature given in the definition. That's fair, that's always the rule with C. So we'll take that hit. And there we go. Okay, so that's a cool system. And now the next thing is when we are... When I am testing main, I don't need to do anything else, I don't think. But if I am the library, then if I were to actually run this, this should be a null function pointer now, and it should crash. And so we got a crash, and I think that that's pretty determinative. That's what we predicted. That's probably what's happening, right? We could pop remedy up and be doubly sure, but I think we know, right, in this case. So let's just move ahead with figuring out how we're going to do that part. I think I talked about that here too. Dynamic initialization. Cool. You know what? I am going to take a 5-minute break, and then we will do dynamic initialization. So here, I'll be like this. Alrighty. And be back in a few. All right. So, dynamic initialization. Here we go. Base init, library open, base, boom. The exact details depend on how you've solved the symbol declaration problem and on the operating system APIs for loading and linking libraries. First option is that when main loads the plugin layer, it is responsible for reaching into the module, finding its base init function, and calling it. The second option is that the plugin module has an onload entry point that calls base init. None of these options are broken, but they do require some extra handshaking and protocol designing between all of these binaries. Automatic initialization. Another option is to have the base layer itself provide the code that does all of the initialization automatically for the users of the base layer. In order to do this, base will need to be able to write something like an onload hook, a function that gets called, style of symbol definition in the before main examples. Right, okay, so let's go and look at those. That's what I need to add to the base layer next. Well, hold on, do I have an example here? Before main, okay, cool. Let's just grab that from the experiment and drop it into my base layer now. Let's see. Shared func. Okay, here we go. Mr. Fourth before main. Mr. Fourth before main. Mr. Fourth before main. Missing for this OS. Okay. And that should really be it. Declares the function, sets a pointer in the space, pointed to that function, then defines the function. Here we do, okay, so you just do before main and then you put in the function body. So that's cool. Now, how did I use that here? Before main. Okay, so what I did was, if we're the file that has to do the symbol imports, then we put a base layer before main thing in down here at the bottom. And that is responsible for loading in all of the functions, which it does by grabbing a function table full of function pointers. Yeah, okay, so let's do this. Let's say, let's see here. No. Since we have a single base layer that combines the base and the OS layer. This is going to be simpler than it was even in the example. At the very bottom here, Mr. Fourth before main, base before main, and now the goal here is to load in the module. Okay. Interesting. So what's actually happening here, what appears to be happening, is we're saying that base is going to become separate from the main, which I'm fine with. And that's going to mean that testing library, import runtime symbols, import runtime symbols. Do we want that to be the default? Okay, let me think through what options there are. Right, okay. All right, we're gonna switch. I'm gonna switch back now because more information is available. I've learned this isn't right. We're gonna go back to Mr. Fourth, define runtime symbols as the name of the option, and define runtime symbols has the opposite meaning to import runtime symbols. So these are flip-flopped, and this is going to be, if we're defining runtime symbols, then do this. Define runtime symbols. If we're not defining runtime symbols, do this. And at the bottom, if... Oh, and this should not go inside of OS Windows specifically. This goes underneath everything. Like this, maybe. Import runtime symbols. Load runtime symbols. Okay. And this isn't if 0, it should be if we are not defining runtime symbols. Okay. What we're going to do is this, and then if good, then what we want is missing load symbol macro for runtime symbol loading on this OS. Okay. Over here we had get proc address, takes an M, takes in N. It's gonna set us, we're gonna want to set N equal to this, but we can't because get proc address is gonna return the wrong type. Do I have a void func? I do. So I'm gonna cast, I'm gonna take the address of N, cast it to a void func pointer, and then dereference it. So now I have a writable, like an L value that modifies N because I took an address and dereferenced it, but I've changed its type to void func pointer, and then I can do that here, and that way it won't matter what the type signatures on either side are, and I don't have to duplicate type signatures with this macro. Same thing here, except I swap out this function. Okay. Load module, define load symbol, and then we just make the list of all of the things that need to undergo this treatment. And right now that's just going to be manually managed. So log accum begin, gathering, emit f, accum end. And you all want to see the module as well. Why don't we just not do that way? Okay. So in theory, what can happen now is if it could load base DLL, then it could initialize these. If it's not able to initialize these, we have a big problem. And not entirely sure what we would do there. Like, I don't have a way to just, I guess I would just emit an error, but I can't because this is the thing that would let me actually talk to the error system in the first place. So this is more like an assert good kind of situation, I think. This has to work or else the thing doesn't work anyway. I mean, maybe what I want to do is say I will handwrite, since I'm already handwriting the DL open in the load library, maybe I'll just handwrite the error boxes that come with these as well later on. Okay. Okay, so we're getting there, but now what has to happen is I was originally saying that this would contain the definitions, but actually it, just like everything else, is importing the definitions. So what we need is over here in testing, or in the build fly, we're actually going to build 2 DLLs, and the first one is going to be Mr. Fourth Base. Okay, so where is it? It's in source path Mr. Fourth Base.c, I guess. But that's not going to work because the default Mr. Fourth Base.c doesn't even include. Okay, so let's not do it that way. Let's do Mr. Fourth Base.target.c or something like that. Go to the source folder, Mr. Fourth Base.target.c. We'll do this, and then we'll do define Mr. Fourth, define runtime symbols, yes. What does that look like? Okay, so what just happened is it built the target.c, which is just the H and C file, but this version defines runtime symbols. Then it built my library and my main. And now my library and my main are both set up to import from Mr. Fourth Base DLL. Hey, check it out. Check it out. Okay, so testing library, testing main. If we go through this, it looks like it put them all in together here. Process beginning, lib begin, lib tick 1, 2, 3, 4. That's these guys. Process tick complete, lib tick 5, lib end gives me a number, and process complete. So that's pretty good. That's it. That's what we wanted to see. Let's go into base.h for now and say we've got some things to do, right? We did this for the log. We still need to do this for error and scratch memory. Hold on. I'm going to clear these out because I'm going to do those again. Change some things. Okay. I think that's a good spot for today. So far, we've got the dynamic linking stuff is working. It requires a small extra amount of maintenance, which is in my base.c. I have to maintain this list in parallel with the shared functions here, and I also have to maintain another list of the initializers for those symbols here in the C file under certain macro or preprocessor conditions. In theory, that could all be automated with an X list, but then you would have to hide this content. Like, you would no longer be able to read through the header file and see all the symbols. And so I'm opting for slightly higher maintenance work on my end. And so maybe what I want to do is think about, like, what is a mechanism for ensuring maintenance upkeep that I could do? How could I improve the odds that I'm catching mistakes or getting it done correctly or whatever it needs to be, right? But I think that's a good place to stop for today. It's good progress. If you've been hanging out, thanks for coming around and seeing what I'm up to. Again, if you want to start checking out the base layer or any of the other stuff in my code base that isn't public, there is a reward if you join, if you become a member. At the membership tier, you get exclusive source access, and over here on my Git, you would have access to more than just this public stuff. You'd see my private repo. You can also find other stuff about this whole membership program over here on my blog and in this video I released about it. So consider, if you like the stuff I do on my podcast and in the streams and on YouTube, and you'd like to support it, that would be super helpful. So yeah, check this stuff out, and thanks for hanging out, guys. I'll see you around.